Hello, hello, geometry students. Almost called you Algebra 1 students. Shame on me. Um, Welcome to week 2. In week 1, we had a brief assignment where we were really just interested in making sure everyone could get logged in to all of their accounts and understand what to do on Manga High. And just a quick reference to that. When you're working on problems on Manga High, make sure that you're working them more than once. Some people were under the misconception that you could just go on Manga High and whip through 10 problems and say, hey, I'm done for the week. This is an easy class. Well, it might be an easy class, but you can't just go through it once. Minimum times through to get a gold medal is going to be 3, and everyone should try to achieve that gold medal. If you understand what you're doing, you should be able to get a gold medal. I'm not going to give you like Fs if you get on there and you can't get a gold medal as long as you're trying. Remember, I can see how many times you've attempted it, and I can see how much time you took to attempt them. So keep that in mind when you're racing through as fast as you can go. It's not a race. It's all about understanding. This week, we're going to have 2 assignments. The first one's going to be due on Wednesday. The second one's going to be due on Friday. So keep that in mind as well. So that means that for the first assignment, you have Tuesday and Wednesday to finish it. And for the second assignment, you'll have Thursday and Friday to finish it. But I believe I'm going to allow you to get started on that second assignment as early as Wednesday. So if you wanted to get started on it early, you could. For today, and this is new information, we're going to talk a little bit about circles and chords. So let's start off and just define what we have. In a circle, the radius is a segment that goes from the center of the circle to a point on the outside of the circle. We call that a radius. Now, we use radius interchangeably. Sometimes we're talking about the segment itself, and sometimes we're talking about the measurement of that segment. But either way, the radius is the segment or its measure from the center to the outside of the circle. Well, what then is a chord? A chord is a segment that goes or has endpoints on the outside of the circle. So it doesn't go through the center of the circle. If it did, it'd be called a diameter. But it does have endpoints on the end of the circle. So a chord is a segment that lives inside that circle and has endpoints on the outside of the circle. Okay? All right. What we're particularly interested in with this is what happens when the radius crosses a chord at a right angle. And the answer to that question is, that means that it cuts the chord into 2 equal parts. So I'm going to put these hash marks to show you that the segment from the outside to the radius, right, is the same length as this segment on the right side from the radius to the outside of the circle. When you have the radius at right angles to a chord, it cuts that chord into 2 equal pieces. In other words, it bisects the chord. All right? The opposite is also true. Suppose that we didn't know what type of an angle this was. We didn't know it was a right angle, but we knew that it did cut the chord into 2 equal parts, that it was bisecting it. Well, if we know it bisects the chord, then we can say the angle formed is a right angle. All right? So it works both ways. The original theorem is if a radius is perpendicular to a chord, then it cuts the chord into 2 equal parts. Its converse is also true. So if the radius cuts a chord into 2 equal parts, then it is perpendicular to that chord. Okay? Let's do a few problems from Manga High, see how some of these work. The first one up here says, the radius OQ cuts the chord PR at a 90-degree angle. This means that the chord PR is going to be cut in half. So if PS, and we'll look at the points, there's P, there's S. If PS is 11, then how big is PR from P all the way to R? I think it's got to be twice as big, or 22, so I'm going to slide that here. And then it says, and how big is segment SR? Well, if it's being cut into 2 equal parts, that must also be 11. So I'm going to place 11 there and check my answer. Woohoo! The radius on OM cuts the chord JL in half. Okay, if it cuts it in half, I know it's going to be at right angles, right? So if this is a right angle and this up here is a 70-degree angle, then I should think about the angles of a triangle adding up to, 180 degrees. So I could subtract 90 from my 180 and then subtract 70, and you'll get 20 degrees for your L, right? Everybody understand what I mean? In this triangle, see, there's a triangle here. We're looking at the angles, and we know all three add up to 180. So I could take 180 minus that 90, then minus that 70, and find out that it's 20 degrees, and put my 20 in here. Okay? All right. The radius OS cuts the chord PR at 90 degrees. Fill in the correct lengths for OR and QR. How far would it be from OR and how far would it be for QR? Well, QR is going to be 23 centimeters right there, right? Because that's the one that's equal. You got little marks on them to say, hey, these are equal to each other. But notice that the distance from Q to O is the same, and I can use some of the theorems we had from before, because these two triangles are going to be congruent by side, angle, side, and therefore their corresponding parts are congruent, making this hypotenuse also 25. Side, angle, side. Okay? Boom. The chord cuts the radius into a ratio of 1 to 1, and the length AC is smaller than the length of CD. Okay. What type of angle is OCD? Well, these two angles are going to be the same because they're vertical, and these are going to be the same because they're vertical. But anyways, if it's not cutting it in half and this segment smaller than that segment, then that means that this angle here that's in pink is going to be an acute angle, right? Smaller than 90. The radius OZ cuts the chord Y or WY in half. Fill in the correct value for angle WOX. WOX. If it cuts it in half, then this one's 90. So once again, we know they all have to add up to be 180. I'm putting it in my calculator here. That means that angle should be 48 degrees. Ta-da! Gee, we only got one more to go to get to the hard ones. Add a radius to the circle that is perpendicular to it. Well, that doesn't look like it would be perpendicular. This one looks like it might be perpendicular if I put it in there. Is there like other ones? Nope, not that one. Does that look perpendicular? By golly, it looks kind of perpendicular. Ta-da! Find the size of angle FOG. It's kind of foggy out. Let's see. FOG. Well, again, we're going to use the fact that these are really going to be congruent triangles, and that's a 40-degree angle. So that's got to be a 40-degree angle over here at G, right? So if they all have to add up to 180, then again, I'm using the idea of that. And I think that's 50 degrees then, right? 50. Yay, 50. Label the lengths of the lines that can be calculated from this diagram. Oh my goodness, there's a whole bunch of them that can be calculated. Well, that one's got to be, we don't know what that is. It's 18. Well, how big is the radius? The radius is 22.5. So if I took 22.5 and I subtracted 18 from it, I'd get 4.5. So this whole length here from O to L has got to be 22.5 because it's a radius. But it's pointing here saying that the little part here is 18. So subtract 18 from 22.5, I get 4.5 for this little length right there. Okay, yay. And then, if this is at right angles, and this segment's 20.5, this one's got to be 20.5. So we're going to put that over there, right? All right. And if the radius is 22.5, then this distance has got to be 22.5 because it's a radius. Have I filled in all my blanks? Okay, submit my answer. Woohoo! Woo! Label the lengths of the lines that can be calculated from this diagram. Well, let's go one more time here. Let's see. The radius is 13, and that's a radius, so it's got to be 13. Kaboom. If that segment's 10, then this has got to be less than 10. That's not a 90-degree angle. Okay. But these are, so that's 12, and that's got to be 12. Boom. How do I know what this one is, though? It's less than 10, but I don't know if it's 9 or it's 8. How would I know? Lengths and lines that can be calculated. I don't know that can be calculated. Oh, I could. No, I can't. It's not telling me how long that is. Oh, hey, it was tricky. It didn't want us to actually do that because we can't calculate it. All right. So we're already on the extreme ones. I'll let you try to work those out. I think you get the idea how this works. Good luck. Remember, you're going to have another assignment that drops on Wednesday that you want to do on Tuesday and Thursday at the very least. Okay? Good luck this week. Hopefully, we'll see you real soon. Take care.